Okay, let's take a look at some scientific notation. So let's write a number in scientific notation. So we have a number between 1 and 9, not 0, a number between 1 and 9, then a decimal, then whatever is after it, times 10 to whatever it is. That is a number in scientific notation. Again, a number from 1 to 9, then a decimal, and then any number of numbers after it, times 10 to the number. It's actually not in the notes. So, as you can see in the notes, 10 squared, 10 times 10 is 100, and 5 times 100 is 500. Plug it into your calculator, check your answer. So let's take a look at 8.43 times 10 to the 5 equals. Well, as you can see in the notes, 10 to the 5 is 10 with 5 zeros after it, 100,000. And 8.43 times 100,000 means that we're going to move the decimal 5 to the right. So let's do that. So I'm going to rewrite the number below, 8.43, and I'm just going to put a bunch of decimals after it. Then, because the exponent is a 5, as you can see in the notes, move the decimal 5 to the right. So 1, 2, 3, 4, 5. I'm going to put an arrow there, and I'm going to put the decimal there, equals. So I'm going to write that number, 843, then I have 0, 0, 0, then I'm going to put a decimal, and then I'm going to circle my answer. Move the decimal 2 to the right. That would have worked in the example above. I'm going to do that in red. I'm going to put the 0, and then I'm going to move the decimal 2 to the right. And notice, we get 500. So, positive exponent means decimal goes to the right. These English sentences are in the notes. Feel free to print off the notes or write out these sentences. But positive exponents moves the decimal to the right. Okay, let's take a look at another example. 243. I'm going to put a decimal there just because I can. Times 10 to the negative 4 equals. So we just learned if we had a positive exponent, we move the decimal to the right. Now, with a negative exponent, we're going to move the decimal to the left. So the first thing I'm going to do is going to rewrite this number down below, 243, put the decimal where it belongs, but this time put a bunch of zeros to the left. Now I'm going to move the decimal to the left 4 times because the exponent is negative 4. 1, 2, 3, 4. Put the decimal where it belongs, put an arrow tip on it so I know where it was and where it went to. And then say equals, I have a 0, and then I have a decimal, and then I have a 0, 2, 4, 3. Then I'm going to circle my answer. Notice I just wrote the answer from here, there, and the answer from here, there. I'll go down the page a lot because it's a lot simpler to see your exact work directly below without scanning left and right, but writing a final answer to the right to save space, whichever. Okay, so now write in scientific notation. So let's take the number 9624, and I'm going to throw a decimal on there. Might have some decimals. Equals. So remember, we need to get the decimal to right here. So how are we going to get there? Well, we need to move the decimal 1, 2, 3 to the left. Now, as again, when we learned above, I'm going to write it in red. Positive to the right. Negative to the left. But now we're doing the reverse process. So the reverse thing must happen. If I move the decimal to the right, then, if I move the decimal to the left, as I just drew the same arrow to the left, then I have to do the opposite thing. So I have to make the exponent positive. So we're going to get 9.624 times 10 to the, and we moved it 1, 2, 3 to the left, so we have to make a positive exponent. So I'm not going to rewrite those rules from above. I'm just going to memorize in red, the box off to the right, what we do in scientific notation to get to regular, and then we just know it's the opposite to get back. Now, every single one of these, check your answer on your graphing calculator. The first one, the second one, this one. Now you have to type in scientific notation, and then any calculator, excuse me, you're going to type in scientific notation, you're going to make sure that the answer is exactly what it was before we manipulated it. Okay, moving down the notes, we have 5 million. 5 with 6 zeros after it, equals 5 times 10 to the what? Well, I'm going to put the decimal in red where it belongs, and then I'm going to put it where it was after the last zero, and we go 1, 2, 3, 4, 5, 6. Arrow tip to remember which direction I went, and we give the exponent a 6. So there are many more examples in the notes. Always check them on the calculator. And there's some little alternate solutions that you can feel free to check out if you want to see different ways of doing things. For example, doing it in 1 step or doing it in 2 steps, and whichever one you feel more comfortable with. So scientific notation and standard notation, always checking on your calculator.